Hey guys, James here, and today we're going to be doing some Lewis diagrams in the Chemistry 151-11 GLA. We're going to be going over problems A, F, and H in Part D. So the problems read, draw the Lewis dot structure for the following molecules or polyatomic ions. And our first problem is NH3. Let's go ahead and look at a periodic table really quickly. When drawing the Lewis dot structures for these compounds or polyatomic ions, it's important to know that each element is only going to use the electrons that come from its outermost shell. These electrons are also called valence electrons, and they can be counted up pretty quickly. So if we go ahead and look at nitrogen, nitrogen's outermost shells include the 2s orbital and the 2p orbital. Now, nitrogen has 2 electrons in the 2s and 1, 2, 3 in the 2p. So that's going to give us a total of 5 valence electrons that nitrogen is going to use when it's bonding to other elements. Hydrogen, on the other hand, only has its 1 electron. And because we have an H3 in NH3, we're going to multiply this by 3 and use 3 valence electrons there. We're going to add these up. So you have 8 valence electrons total that need to be used when drawing the Lewis dot structure for NH3. So we know we have 8 valence electrons. We can start out by drawing N as the central atom, bonded to 3 H's, because we know they have to be connected to each other somehow. Each of these bonds have 2 electrons inside of them, so 2, 4, 6 electrons are already being used up. That gives us a total of 2 valence electrons that need to be used, and the only place that we can put them without violating the duet or octet rule would be right here on the nitrogen. So if we count these up, nitrogen has 2, 4, 6, 8, hydrogen has its 2, and this is going to be the structure for an NH3 molecule. Next we'll look at HCN. We already know that H has 1 electron in its outermost shell. Nitrogen we just did. Nitrogen has 5 valence electrons. And carbon has 2 in the 2s orbital and another 2 in the 2p orbital. So it's going to have 4 electrons. We'll add those up. That's going to give us a total of 10 electrons that need to be used when drawing the structure. We'll go ahead and make C the central atom, connected to an H and an N. There are a total of 4 electrons being used up in these 2 bonds. So we can subtract 4 electrons from 10. And we know that we have to put 6 more electrons somewhere on this molecule. We're not going to be adding them to hydrogen because we know that we can't violate the duet rule there. We could add them to the carbon or the nitrogen. I usually tend to add things to elements on the outside first. If we go ahead and look at this right now and try to see if we've completed the octet rule for each of the elements, we'll see that we haven't. Although nitrogen has its 8 electrons, carbon only has 4. So in order to correct that, we can take these 2 electrons from the top and make a double bond between C and N. Nitrogen still has 8 electrons, but carbon only has 6. So we can take another set of these electrons and make another bond between the C and N. Now hydrogen completes its duet. Carbon has 2, 4, 6, 8 electrons attached to it, and nitrogen also has 1, 2, 4, 6, 8 electrons attached to it. So this is going to be the structure for the HCN molecule. Next we'll be looking at H3O+. Hydrogen has 1 electron. We have 3 of them, so we have 3 electrons there. Oxygen has 2 coming from the 2s orbital and 4 coming from the 2p. So that's going to give us a total of 6 electrons. We can add those up, and that gives us 9 electrons total. But because there's a plus charge on this compound, what we're going to do is subtract 1 electron away from it already, and say that we have to use 8 electrons when drawing the structure. So we'll make oxygen the central atom, attached to 3 more hydrogens. We have 2, 4, 6 electrons being used up in those 3 bonds. So that gives us a total of 2 electrons that have to be placed on this molecule. We can't put them on any of the H's. We're going to go ahead and add them to the O. And this is where you get something called a formal charge. This plus ion resides on the oxygen because we know that in its natural state, oxygen wants to have 6 electrons, but if you count up the electrons that it's actually touching or holding onto right now, you'll see that it has 1, 2, 3, 4, 5 electrons, and so it's 1 electron short, which is why it has this formal charge of plus, or plus 1. And so this right here would be the Lewis dot structure for the H3O plus molecule. Thanks guys, and I'll see you guys soon.